What if we want to extend that into normal random variables? Is anything different? Okay, so if X and Y happen to be independent normal random variables as opposed to discrete or continuous, then AX plus BY, so a linear combination of those variables, is also normally distributed. And in the same way, the expected value of AX plus BY is still A times E of X, B times E of Y. Similarly, the variances are exactly the same. So nothing changes, all right? But if we want to start working out some values with it, if we're preparing a house for painting, okay, so it takes time to paint and it takes time to prepare. So the time taken to prepare the house for painting is normally distributed with a mean of 6 and a standard deviation of 4. The time taken to paint the house is also, it's independent of that, and it's also normally distributed with a mean of 18 and a standard deviation of 3. So if you want to do both processes to your house, what's the probability that it's going to take me more than 19 hours to fix that up? So we need to know the mean and the standard deviation for a normal distribution to be able to work out a probability. So the mean of that, of both tasks together is going to be 6 plus 8. So the mean time to get the job done is 24 hours. Now the standard, or the variance, if you like, the variance of each job is 3 squared plus 4 squared, isn't it? So the variance of the individual task is actually equal to 25. So we could say that both tasks together is distributed normally with a mean of 24 and a variance of 25, or a standard deviation of 5. So the probability that X is greater than 19 is the probability of, well, there's my X value, the mean, standard deviation. So that's the equivalent of Z being greater than -1, which we know is approximately 0.84, okay? 2 standard deviations, or it's 1 standard deviation above and below, will give me, well, a greater than 1 standard deviation or below will give me a probability of 0.84. Or we would use our CAS. If we wanted to use our CAS to get an exact answer, we go normal C to F. I want from -1 to infinity, and that's a 0, 1 distribution, isn't it? Okay, since I've got the standard values. Or I could have done normal C to F of what I want to be. I want to go greater than 19, so 19 to infinity, a mean of 24 and a standard deviation of 5. They'll both give me the same answer. All right.